Welcome to Class 9 Maths. Today we explore polynomials completely. A polynomial is an algebraic expression where every variable is raised to a whole number power 0, 1, 2, 3, and so on. No negative powers, no fractions as powers. We classify polynomials by their degree, the highest power present. Degree 0 is a constant. Degree 1 is linear. Degree 2 is quadratic. Degree 3 is cubic. And the zero polynomial, p of x equals 0, has an undefined degree. A0, or root of a polynomial, is any value of x that makes the entire expression equal to 0. On a graph, these are the points where the curve crosses the x-axis. For any polynomial of degree n, there are at most n zeros. For a quadratic ax squared plus bx plus c, Vieta's formulas give us a powerful shortcut. The sum of the two zeros equals minus b over a. The product equals c over a. For example, if the zeros are minus 4 and 6, their sum is 2 and their product is minus 24, so the quadratic is x squared minus 2x minus 24. When you divide any polynomial p of x by g of x, you always get a quotient q of x and a remainder r of x. The remainder theorem gives us a brilliant shortcut. When dividing p of x by x minus a, the remainder is simply p of a. Just substitute x equals a directly, no long division needed. Example, if dividing x cubed minus 2ax squared plus 16 by x plus 2 gives remainder 0, then p of minus 2 equals 0. Substituting gives minus 8 a plus 16 equals 0, so a equals 1. The factor theorem is a direct consequence of the remainder theorem. If p of a equals 0, meaning the remainder is 0, then x minus a is a factor of p of x. This works both ways. It extends to any linear factor. Ax minus b is a factor of p of x if and only if p of b over a equals 0. These 8 algebraic identities must be memorized in both directions, expanded and factorized. The geometric proof of a plus b squared shows a large square split into 4 areas. The most powerful one is the conditional identity. If a plus b plus c equals 0, then a cubed plus b cubed plus c cubed equals exactly 3abc, with no calculation needed. For example, 30 cubed plus negative 18 cubed plus negative 12 cubed. Since 30 minus 18 minus 12 equals 0, the answer is simply 3 times 30 times negative 18 times negative 12, which equals 19,440. 5 errors that cost students marks every time. 1. A plus b squared is not a squared plus b squared. You must include the 2ab middle term. 2. When distributing a negative sign, every term inside changes sign. 3. If p of minus 5 equals 0, the factor is x plus 5, not x minus 5. 4. Whenever you divide by x minus a in a proof, state that x is not equal to a 5. In synthetic division, always insert 0 for any missing power. That's the core of the polynomials chapter. Subscribe for part 2 covering advanced techniques. See you next time.